Okay, we are going to dig into creating some better game logic for a specific game rather than just, a drawing and playing card game. Um, First off, if you pay attention closely, we are able to see the other player's hand, which is not ideal. It's only for a moment, but let's add some logic there. So in our card list, we have something called we have the playing card here, and we have this visible. So there's a couple ways we could do this. Um, but I think the best way is let's actually pass through um, a variable here. Actually, no, we can do this because we already know the player. So we can very easily just actually go player dot is human. Now this logic will fail if this became a multiplayer game and we need something that kind of tracks, that the player is the one, operating the UI. But if we were to do this now and, for instance, let's draw a card, end of turn, we should see that that card is blank. So yeah, just a little thing there. We could always, for debug purposes, turn this back on so we can see what they're doing. And in fact, maybe I will do that for the purpose of building this game. But just so you know, we have that option there. So now if I draw a card and my turn, we can see that person's card, and there they played it. Okay, so I'm going to close a bunch of stuff because we're going to kind of start something new now. So we have our provider, which is in this folder called providers. I'm going to make a new one called Crazy Eights Game Provider Dart. And this isn't a widget, this is a class, and it's going to be called Crazy Eights Game Provider. And it's actually going to extend Game Provider. Oops, extends. Then let's open up Game Provider. And we're going to make this an abstract class, meaning it can never be instantiated on its own. It's meant to be inherited, and then you work with it that way. So if I do save now, you're going to see literally that error. Game provider is an abstract class and cannot be instantiated. So let's go back to our main.dart. And instead of doing game provider, we'll do crazy eights game provider. So that's one thing we have to do. Now we're going to see some other errors. Um, not showing up there, but either in our game screen or probably in our game board, wherever we have our consumer, basically. It's expecting it to be game provider, but let's make it crazy eights game provider. Now, if we refresh, we do want to do a hard refresh because that's kind of a dirty change. Okay, so we are seeing another instance, another problem here. Let's just see where we have game provider. Main, Crazy Eights game provider, that one's fine. Crazy Eights game provider, this is our class we just made. That's our abstract class. Oh, yes. Also, we have a instance of our game provider here, which needs to also change to Crazy Eights game provider in a couple spots. And everything else should work now, in theory. And we go back here, and there we are. Now, this will behave exactly the same way because of the way inheritance works. Anything that is a public method of game provider, so discards and new game and setup board and everything, you can call. I can basically call that from here. But the beauty is we can actually do some overrides of various functions. So for instance, let's take our setup board function, and we're going to make it a little more like how would a game be set up in Crazy Eights. So what we're going to do is actually do a loop. We want to, for each player in players, we're going to essentially draw some cards. So we'll await draw cards, and the player is P in this case. And we actually can, instead of just drawing one, we can do 8 because that's how many cards you get in Crazy Eights. And it should be good. Now, there's one little thing that is going to be a problem. Because really you can only draw cards on your turn based on our current logic here. So we're going to make another variable here called allow any time. By default, it's going to be false. And we can go right here, can draw a card. It would, this, we kind of want to override this. So we can go if not allow any time and not can draw a card, then return. So now if we are able to pass that over like this, allow any time, true. So that'll kind of, it's basically not going to worry about calling this. Is this logic right though? Can draw a card. Yeah, I think that logic will work. Okay, so we have that. So that will, well, let's just, let's see this. So this is, oh, we forgot one thing. Whenever you're overriding a function in some inherent, you put this override. This is like when you're, overriding the init state of a class, because init state's a function that's part of a stateful widget. So you can override it like this. And we didn't save a file, so let's save that. So now if we actually reload the game, new game, we see that we're both given 8 cards, and the deck is now less. So that's great. Now, one other thing we want to do after we do that is actually draw something to the discard pile. So we don't have a function for that yet. We could make it in here, no problem, but this sounds like something that many games could, make use of. So let's make that function, and I think it can go kind of after here, future void draw card to discard pile. So this is kind of like going to be similar to the drawing cards function, except it doesn't go to a player, it just goes right to the discard pile. And let's do this, an int of count equaling 1 by default, so we can draw multiple ones. This is an async function. And we'll do a draw. So we'll use final, we'll call it draw, and it equals 08. This is very much like the function functionality down here. And we can do service.drawCards, and we will pass in the current deck because we're doing it from the current deck, and the count will be whatever that count is, 1 by default. So we have that, and that's just drawing the card. Now we have to put the cards in the discard pile. So we can do this a couple ways. We can go discards equals and take whatever's in the discard and spread it, or we can just do it this other way, which we can just go discards.add all, meaning instead of passing in one item, we're actually passing a array, a list in, and we'll use that draw cards as that. So it's going to kind of combine that array. And of course, we want to, anytime these things happen, notify listeners so that our widgets rebuild. So then over here, we can go and draw cards to discard pile. And what do we want to draw? Count of 1. 1 is good. So we'll just leave the default. And that is good. Okay. Okay, there we go. So let's just see how that all works. We'll refresh. New game. And all that stuff happens. And look, that got taken from there. Draw cards from discard pile. I feel like one little thing didn't. I feel like we missed one thing here. Did that? Let's calculate this. There's 52 cards in a deck. We subtract 8 for each player. 36, and there should be 1 less. So there is some issue here. I feel like we missed one thing. Right. So we had this line. We need to also remember in the draw card to discard pile, we also want to subtract whatever's in the current deck by. Now we can just do it this way, because when we do a draw, we get back the remaining. Okay, so one more refresh, and we should hopefully say 35 after all this. Yep, 35. So 8, 8, and 1. Okay, very good. Back to our Crazy 8 game provider. So we have like an override for setting up the board because in Crazy 8s the game is a little bit different. What else is different? Well, lots of things. Um, okay. Yeah, so one thing we should definitely be thinking about overriding is, and I should be able to just type this, can play card, which I think is can play card there. And this will be this will return a Boolean. It's an override of this card model. So just kind of basically just copying this. Looks like we need to import this guy. And currently the default one is this, but when we override it, it's going to be using this. So we're going to have some logic in here to be like, can I actually play this card? Now, in Crazy 8s, there's a few rules. First of all, it's based on kind of like what the last card was played. So we want to kind of keep track of that. Now we know it's the top of the discard pile, but not every game, uses, a discard pile kind of thing. So what I want to create kind of in our main provider is just something that, we've already set it up. We have this thing called game state here. And this is just gonna be a way where us as the programmer can kind of remember things and keep them in memory between turns and that kind of stuff. So what we can do is we're going to make a variable called can play, and we're just set it to false right off the top. And at the very end, we're going to return that value. And the reason we're doing this is because there's multiple conditions that can ultimately turn this to true. So we're just going to kind of go through the different conditions and set it to true if it can, and then when it gets to the end, we know we're good. So what I want to do is, first of all, we need a way to know what card is at the top of the discard pile. Like I said, we could just, look at that by the top of the discard. But I want to kind of make use of this game state sort of thing. So we're going to go back to our game provider, and anytime we play a card, we're going to go game state, and we're essentially going to make something called, like, for instance, like last suit equal to whatever that card dot suit is, right? Now this gets a little bit tedious using strings like this because you might make a typo in one and everything will become a problem. And we could also, like, the game state could be like an object that has, properties like, card dot suit. But the idea of this game state thing is it should just kind of work with every type of game. So we are purposely keeping it a little bit open-ended. But rather than just having strings, let's go to our constants file, and we're going to make a constant called, and I'm going to just start these with GS, meaning game state, and we'll call it like last suit. And we can really put anything here, but it makes sense to just kind of use like last suit or something like that, or even keep it the same. Really, this could just be a random string as long as it's, not, as long as it's unique, it'll be fine. And we'll do last value. So these are just kind of like the keys. So that here, instead of typing this out every time, we can just go like this. And we need to import that. So we can do that, and we can do gs last value equals card.value. So now anytime we play a card, this is going to replace whatever was in here at that given time. Meaning over here, we can do some things, and we can look at our game state object because it's a part of the thing we're inheriting, and we can check, gs last suit. And what we can, first of all, in this game, just to kind of solve all of our things right off the bat, if the last suit is null, or game state gs last value is null. So if these are null, meaning no card has been played, a card can't be played. Hopefully that never happens because we'd be stuck in I don't know what you could do at that point, but we'll have that in there to kind of protect us. The next thing we can check in Crazy Eights is as long as the suit matches, you're allowed to play it. So we can go if it equals card.suit. We're just going to set can play to true. Similarly, we can check the last value. If it's equal to card.value, can play equals true as well. Now there's a few other things. Let's add in if card.value is equal to 8, because in Crazy Eights an 8 is wild and you can play anytime. We can also say can play equals true. So in theory at this, we could also just be returning true, returning true, returning true, and then returning false at the end. But I want to return the game's, not game state, but sorry, return can play. Just so that we can have more logic without just returning right away. Like there might be things where, okay, that was true, but then at the very end, maybe there's a condition that, but like, oh, but if it's the queen of spades, you can never play. So this just allows us to be more flexible with our rules, but feel free to kind of write your logic the way you want it. Okay, so that is cool. Now, one thing that's missing is in our setup board, we do need to kind of say, hey, that whatever that last card was needs to, we need to update the game state with whatever's at the top. So what we're actually going to do is rather than, so a couple ways we could do this, and I'll do it the one way first. So we drew the card to the discard pile. Let's actually await that because it is an asynchronous function. And then we could kind of take this same logic here and go like this. But instead of using card.suit, we can use the discard. Discard top is a property we have. And we know there's something in it, so we can just do that. So that's fine. That's going to take whatever's at the top of the discard and do it. But why don't we make a function that kind of that we've already like repeated the same code more or less a bit. So let's put this somewhere around, yeah, the draw card from discard pile, I guess. And we're gonna just call this set last played. And we're just gonna pass in a card model card. And essentially, I'm gonna copy this, and instead of saying discard top, we will use whatever that card is, card. And then, so that is good. So that means instead of doing this, we can actually go set last played, and we can take discard top and pass that in. All right, and let's just make sure whenever we are calling this, we're notifying listeners, just in case. Similarly, where did we have this? Let's also do the same thing here. Set last card played to card, in this case, and we can get rid of this. Okay, so let's see if this even works. So there's a 3 of spades. If our logic is correct and I didn't miss something, I should be able to play the 7 of spades. Oh, my turn. Hang on. Let's end my turn. Okay, let's just refresh. New game. Oh, right. Yeah, we do need to refresh for this. So I should be able to play the 5 of diamonds, which I can. Now, here's a problem is, oh, it actually maybe magically worked out. Okay, so now we do have to draw just because our business logic is that. Let me try and play the 7 of clubs. So I'm trying to play that. I'm trying to play the 2. I'm trying to play the ace. I'm going to play the queen. It does work. So it is this logic is working as expected. We could, we're following these rules. Everything is good. Okay, we also need to override some other stuff. So can end turn, for instance. Currently our can end turn, and I should be able to just go can end turn, boom. And we'll just turn this into a normal function. So in Crazy Eights, what is the rules for ending your turn? You need to either at least have drawn a card, or you need to at least have done an action, meaning playing a card. So what we can do is we can go if turn, and in this case, so because we're working within our sort of like sandbox of crazy eights provider that's extending this, we can actually no longer work with a private property. Like you can't even access turn, which is why we have those getters and setters and everything. But I can access, turn without that. So I can go to if turn.drawCount is greater than 0, or turn.actionCount is greater than 0. Then we know we can end the turn. Otherwise, we're going to not be able to end a turn. So that will kind of slightly change our logic. And the difference is, let's just kind of get through another one of these as work. So let me play the Queen of Hearts because it's the same value, end turn. Let's see. Okay, so now I can't end my turn, but if I was to, in theory, if I was either able to play or pick up, I should be able to. So let's just try playing. Yep, I can end my turn. And in this case, let's try just drawing, and look, I can end my turn. So that logic is working fine. Now, there might be something weird happening with the bot, because there's definitely some weird stuff happening with the bot. Let's fix that. Okay. So this bot turn is just like, hey, I'm just going to draw and I'm just going to play my most recent card. And it probably doesn't even do anything half the time because remember, if it can't play the card, it just returns. So let's override our bot turn function. And I'm just going to grab this and remember to override it. So the logic here is going to be a bit different. I do like, I do want to kind of add one of these awaits in. It's just fun. It makes it think that the player's thinking about it. And what we can do is let's loop through all the cards that the bot has. So in turn.currentPlayer.cards. So we're just going to loop through C, and we can check if can play card C, and that's going to use that same logic here. Then we will do stuff. So if it can play that card, we're going to await play card. And in this case, we're going to pass in this turn.currentPlayer. And just to simplify things, let's make something called P equal to turn.currentPlayer. That way we can kind of just call this P here and call this P here, and this would be C. And if the player was able to play a card, they're going to play it because that's just good strategy. Play it if you can, and then it's going to end its turn. And then we want to return out of this function fully because we don't want it to then go to the next card and continue. Now, let's say it gets through all of these and hasn't returned, meaning it can't play a card. Let's give another little, oh, I'm really thinking about this. I feel bad. And then we want to draw a card. So draw cards right there. And we got to pass in that player, and we got to pass a count, but the default is already 1, so we can ignore that. And then let's await again. They just do their card, they're thinking. Now, because in Crazy Eights you can draw a card and you can decide to play that card, we want to then go and check. So if can play card. Now, where do we get this C from? Well, we can look at player.cards.last because it's going to be the last one in their hand. Then we can go and await. And this would be p.cards.last. And we'll await that. And either way, at the very end, we're going to end the turn. And let's remember what end turn does. End turn.next. Yeah, and everything should just work. Okay, so now we have a smarter bot. Obviously, you could really blow this out and kind of find out, okay, what card, instead of just playing the card immediately, you could find a list of all the cards that are playable and write strategy on, different things. You might have, maybe you have a 7 of diamonds and a 7 of spades. Well, if you have both of those options, you might want to look at how many spades do I have in my hand, because I probably would rather change it to a suit that is more obvious or more easy to play later. That's basic Crazy 8 logic. There's a lot more. So this function, in a proper game could probably be the longest function in your entire program. But I think this is totally fine for learning purposes. Just going to play the first card it finds. You could also do stuff like randomize the order of your cards just so that feels a little more random. But this is totally fine. Okay, so we're restarting the game, and let's see if this game, even works. Wow, so I can't play anything. I'm pretty sure I'm gonna try. Can't really play anything, so I'm gonna draw. And I should see another card came, and we're just gonna end our turn because we can't play. Okay, so I guess that I wasn't paying attention, but it seems like the bot maybe played. We will pay more attention this time. I should be able to play the three of clubs and end turn. Let's see what they do. So they played the king of clubs. Great. So our logic is working fine. Let's play the 10 of clubs. They played the 10 of hearts. Hey, this is great. I'm going to play the 10 of spades. Okay, 4 of spades. I can play the 4 of clubs. Hey, this is turning out to be a pretty exciting game. No plays for me yet. Now there's an 8. I can play this because we have that logic says can play 8s, but currently there's no way for me to choose a new suit. So I imagine it's just going to be spades now, which it is. So that was kind of cool. That just worked. I can't play, so I'll draw, and I still can't play, so I'll end my turn. Uh-huh. Okay, and look at this. End turn, and now we don't have any logic to be like, hey, the game is over, this person won, but we just got beat by our own AI, which I am equally excited and mad about because that AI was not very good, but I guess the luck was not on our side. Okay, so yeah, next section of this video, we will be going into a couple things. One, we want to deal with these side effects. So, for instance, playing a jack is miss a turn. Playing 2 will require the other person to pick up 2. So we want to do some stuff like that, as well as add some kind of like notifications, essentially like toasts, if you will, that kind of say things like, you have to pick up 2, that kind of stuff. And then we need obviously game logic for, hey, the game is over, congratulations, as well as it might be helpful to have something generic that kind of symbolizes like what kind of card is playable, like what is trump right now, if that's even the right word in Crazy Eights. So we'll catch you on the next one.